I'm going to demonstrate the laws of reflection of light by using a laser, protractor, some basic stationery, plane mirror and the screen. So screen is nothing but a white background. So I had a small piece of cardboard on which a small box on which I have attached a white A4 size paper. So this is going to act as our screen. Now what happens is, this is the mirror, and the first law states that incident ray, reflected ray and normal, they all lie on the same plane. So that can be easily demonstrated even without the use of the protractor, and you will understand why we are using protractor, because the second law states that the angle of incidence and the angle of reflection are same. So we need to prove that. So here I am going to use a red laser, right, in order to support my demonstration, and anything which you see in the mirror will be the reflection. We are supposed to concentrate on this white screen. Okay, so this is our incident ray. The incident ray is this one, which is seen over here, and you will see that the reflected ray will also be on this particular white screen. So this white screen is nothing but, you can consider this as y-axis, this as x-axis, and this will be z-axis towards us. So this white screen is nothing but xy plane, and the incident ray and the reflected ray would definitely be on the xy plane. And from here, if you draw the normal that separates both incident and reflected ray, you will see that all three will on the same plane here. So I'm shining the red laser from this side, and you can clearly see the incident ray and the reflected ray as well. So incident ray, this is the incident ray, that is the reflected ray, and the normal is here, and you can see that all three lie on the same plane. To have a better view, I have switched off the light in the room, and now this is very well visible that this is our incident ray, that is our reflected ray, and here is our normal. And this point where the laser light would strike on the mirror, that would be the point of incidence, right? Now unfortunately I doesn't have another stand so that I can hold this laser, so I am doing it by my hand. So the point of incidence may keep on changing, but hopefully the idea is you have understood. Okay, so we are good to go for the second law of reflection, that is angle of incidence is equal to the angle of reflection. And what I have done is, the same cardboard box on which I had fixed this A4 size paper, and now I have also fixed a protractor on this white A4 size paper so it doesn't move, with the help of a glue, right? Okay, now what my plan is, that this is my plane mirror, and this plane mirror I am going to arrange perpendicular to this plane of paper, correct? So I am going to put it somewhere here on the protractor, and I would make sure that this plane mirror is perpendicular to the plane of paper and along this line, right, like this. And now I would make sure that this mirror does not move, so I will hold this mirror rigidly. Now I will pass the incident ray through here, so it would strike the mirror and it will go somewhere like this. So this would be my target point. I am planning to incident the light at this point, exactly at the middle point over here. So that would become the point of incidence, and this would be the direction of my incident ray. So incident ray would pass from here, it would strike and it would go like this, right? And I would be passing through this 30 degree, right? So in this particular case, this is our point of incidence. So this is our incident ray, that is our point of incidence, and perpendicular to the mirror there is always a normal. So this is normal, so that is 30 degree, and the normal will always pass through 90 degree, because from here the perpendicular line passes through 90 degree. So this is our normal. So this angle is 60 degrees. So I am making sure that the angle of incidence is 60 degree, because this is 30 degree, this is 90 degree. So the angle of incidence is 60 degree. So if I am passing a ray of light through 30 degree, I should get the ray of light from the other end also as 30 degree, right? So let us do that. Through this laser light again, I will pass the incident ray through 30 degree. So this is my incident ray. It is going to strike at the point, and after reflection, as you can see, it passes through the 30 degree only from the other side. This is 30 degree and this is the same point, and look, this is the reflected ray that is on the same 30 degree on the other side. You can see here this is 30 degree. So your attention should be over here, correct? Have a look at it once again. I am passing the incident ray from 30 degree. It strikes exactly at the point that we decided. And there you see, it passes from the 30 degree mark only. So that means the reflected ray is on the other side of the normal, and the angle of incidence and angle of reflection are the same. So hopefully guys, you have understood this demonstration,